Substitution can work out really nicely when you're solving a system of equations, but it's not always that easy to get one of your variables by itself in one of your equations. And that's where elimination comes in. So my first example here for solving by elimination, we're going to solve this system. 3x plus 7y equals 15. 5x plus 2y equals -4. And as you can see, both variables in both of my equations have coefficients. They have numbers in front. So neither of these equations make it really easy to get one of our variables by itself. Again, that's where elimination comes in. So the goal of elimination is for us to be able to either add or subtract our equations straight up and down so that one of our variables can get eliminated. So before we can do that, I guess I'm going to write that out. The goal is to eliminate a variable, by adding or subtracting. And sometimes you will have the same coefficients in front of one of your variables, like maybe they're both 3x and 3x. Maybe they're both 7y, 7y. You might have the same coefficient with one of your variables. In this case, I wanted to make it a little more complicated, so we don't have them. We don't have the equal coefficients to start. If you have a situation like this, we can multiply our whole equation by something. We just first have to figure out what variable do we want to eliminate. Okay. And just looking at this equation, my first thought is, okay, let's eliminate the x's. And it really doesn't matter. But I'm going to choose to eliminate my x's here. And to do that, I see I have 3x and 5x. What would their least common multiple be? 15. So 15 is the smallest number that can divide by both 3 and 5. And to get there, I'm going to have to take this whole top equation, both sides, times 5, and my whole bottom equation, both sides, times 3. So I'm going to rewrite each equation after I've done that multiplication. That gives me 15x plus 35y equals 5 times 15 is 75. And then same thing with my bottom equation. 3 times 5x is 15x plus 6y equals -12. Alright, now that I've done that, I notice I have the same coefficient. I have 15x with both equations. In order to eliminate my x's, I need to subtract these equations straight up and down. 15x minus 15x is 0x. They eliminate. 35y minus 6y is 29y. And then 75 minus -12 is 87. At this point, let's hope this works out nicely. Divide both sides by 29. And it does. Y equals 3. Once we're here, we can go through the same process that we did after we found one of our variables for substitution. Plug this value back in, and we could use either one of our original equations or either one of our equations after we multiplied. Either one would work. Just looking at my equations here, I think this bottom equation is going to be a little bit easier to use because I have a 2y here instead of a 7y. But it really doesn't matter. And I'd have 5x plus 2, but I know y is 3, equals -4. (5x plus 6 equals -4). Subtract 6 from both sides, and divide by 5. I got x equals -2. So I'll put this together to get my solution to my system, -2, 3.